Let's dive deep into our first script. In this lesson, we're gonna talk on how we can use a script. We're gonna see nodes later on once we know how to use scripts, how to attach scripts and manipulate. So let's create a new scene. We can create a normal node scene. We can attach a script by clicking this button here, or we can create a new script in this way. We don't inherit from anything beside our node. We write our first script and this window is gonna open. So now on the very first we have the extension. We extend from node, we inherit from node. So everything we're gonna have in the script is gonna have this parameter inside node. If I have a node to D and add the script, our second script, we extend from node to D, we can use this transform over here. So right now let's focus on the built-in function of our engine. So our node has some integrated function. If I write function is a way to declare a function, the word func. If we write underscore, we're gonna have all the integrated function that our engine already provide to us. Between this one, we're gonna focus on 4 main functions. The first one is enter 3 auto completion. If you click tab, you're gonna have the complete for you. We're gonna write another command, is pass. So it always requires something inside the function. If I don't write anything, it's gonna give me an error. Well, here we can see the error. We expect an indented block after function declaration. So after the function declaration, it expects that something is going under it. So Godot, it's a typing, or GDScript is a typing like language. It requires for you to indent compared to other languages like C or C#, C++, where you can just write everything even in one line and everything is gonna work. So in order of execution, when we have a function, we need to add a space over here. We can click tab. You're gonna have this arrow over here. It means that there is 1 tab. If I click again, 2 tab, 3 tab, it's very useful because it helps us to keep the code clean. So I can write, for example, a print, we're gonna see soon, and I can write the if something, then you do something, and I have another indentation, else you do something else. Like this. Right now it gives error because I just wrote gibberish, but we're gonna examine it later in details. So our first function is enter 3. This function trigger every time a node enter a scene. So this one is our first or second script. I forgot. This is our first script. We're gonna move this one. We're gonna assign to our node. Extend from node. You can also extend if you write node to D. You're gonna extend from node to D. You're not gonna have any error, but there is no point since we're having a node over here. So in our first script, we need to save the scene. Let's write it in scene. We have this function enter 3. Every time a node enters the scene, this is called tree. So if I have more node, I duplicate, Control D, I'm duplicating the nodes. I can move nodes inside and have nested nodes. So this is a tree. Every time a node enters a scene inside the tree, it's gonna trigger this function. Now there is an important way to execute. If I right now click over here, you're not gonna see anything. But as we saw before, if I go over here, I can see this tree. So our root will call our node. That will call all the rest of the node. This is when the nodes enter the scene. So we're gonna go do an example. Let's dive first inside the function. So what we see over here is the function declaration. You're declaring a function. This is the name of the function. Right now is something that the engine has, so we don't need to worry about it. The parentheses, we can put some parameter inside. We're gonna see it later. And the arrow void. This one is the type that this function needs to return, because this function can return one thing. So you have a function to do a calculation and you want to return the result to another things. We're gonna see it later as well. Then we have 2 points. It means, okay, the function is starting from here. So we're gonna see the first command is print. Even here we have a lot of prints node. This is property, print error, print row, print tree. We're gonna see the first one, print. So print is also a function. It's an integrated function that we're gonna call. When I add parentheses, I can express my parameter, my arguments. So it says like that it's accepting an array. Don't worry about it. This one is something that will come over later. We want to use a type string. So a type string is something that contains characters. If I click this, if I write this double and I write my hello world like every other first script, you're gonna specify that you want to print this string hello world. So if now I'm gonna run my file over here, we're gonna see, oops, where did it go? Oh, I need to click this one. We're gonna see our hello world in our output window. So our node entered the tree. Our node, first node, we're gonna delete this one. I'm gonna delete all of this one as well. So our first node entered the tree and it wrote down hello world. So entering the tree triggered this function. But what happens if I click here on my second script, another function called enter tree with a print statement and hello hello world from the child node. What do you think it will trigger first? So let's see. Click. So the first node is gonna trigger the hello world, and sequentially every other node below this one is gonna trigger the other statement. This is very important, the execution. We're gonna see now another function. So when I call this one, the first script, I'm gonna write the hello world. If I have more nodes, I'm gonna write sequentially everything else. The second function that I want to call, by the way, we're not calling a function because you're calling a function when you write this name. We are declaring a function, but these are built-in function. When we write these things, we're gonna override a function that already exists inside the engine. the other function that I want to call is the ready function. This ready function as well doesn't return any parameter, anything, and doesn't get any argument. So if I write down now our print statement, and again, hello from the ready child node, and the same we're gonna do with our first script function, ready print hello world from ready. What do you think is gonna trigger first? Now, logically, it should trigger the first node as well. But if I call it, if I execute, we're gonna call our enter tree, and then we're gonna call the child node. It's ready. It's saying like, okay, I'm ready to do stuff. And then our first node, our root, is gonna call the ready function. There is a reason for this one. We're gonna see it later. I can give a hint. So let's say all these nodes are player, words, enemy, and they is setting up. So you finish to set up all your node, and you're gonna tell to the main node, for example, okay, we are ready. Now you can start the game. Okay, you can finish the loading, or you can activate the input for the player. So there is a specific reason for this thing, but we don't need to worry about right now. Another important thing is the process. That is the process. If I write print hello processing, we're gonna delete these things. If I click Control Tab, you see after I select everything, Control Tab, some hashtag are gonna appear. This one is for commenting. You can create comments, and when the engine see this hashtag, it's gonna ignore. So if I write down hello, I'm a comment, ignore, our engine will not even like calculate this thing. We're gonna do the same for our second script. So Control / commenting. Now I don't want to show in both of them. We're gonna see it just in one. If I now execute the scene, these things happen. It's processing and counting more and more and more. If I click this button over here, I'm gonna squeeze everything into one single line, and we can see that it's counting 1,000 and going on. So something is happening here. It's processing the scene all the time based on something called tick. Now there is two kinds of processing. I want to show you this. There is a function process delta and a function physic process delta. So you see we're passing inside an argument. Right now we pass it because I want to show what happened. So let's delete the processing part, the print statement processing. If I'm passing this argument, and I can use it however I want. If I write down here print is delta, I'm taking this parameter and passing it over here, and I click run the current scene. You see something is happening here, and it's very weird. So it's processing right now. It's processing at the right timing, but sometimes these weird things are happening. If I can't trigger it, but sometimes they're happening, and there is a specific reason. Let's stop the happen again. Let's stop again. If I now print over here the same statement and we pass the delta, the processing is stable. It's never gonna split. The tick is still the same. So this is happening because the physics process is refreshing the updating the scene based on a frame rate we specify in the project. So it's trying to keep the same frames, the same tick for all the scene. Meanwhile, in the process, if you have a faster computer or a slower computer, it's gonna affect your processing. Physics process usually is used for physics. So if you want to emulate gravity or moving stuff, the physics process. If you hover over it, you're gonna see details of the function, what the function does. You can read around code once on each physics ticks and allows nodes to synchronize the logic with physics ticks. And there is also these things over here. You click, you're gonna see what's happening. We're not gonna see it now, right now. But I can tell you this number if I'm going on my project settings over here, project settings, and I check on my settings tick. Let's see if I find it every time. I don't know, where is it? No, maybe it's gone under frame rate. If I go, yeah, okay. Physics ticks per second under physics common, we have 60. Now, if I take my calculator and I go to check my second, 1 second divided 60 tick, it's gonna give me this number that is exactly this number over here. So you know that in 1 second you're processing 60 frames, 60 ticks. Something is happening very fast at the same frame rate. So you don't have any jittering or like jumping frames or slowing down, because everything is fixed compared to the process. So once we know this one, we can proceed to the last function, is the exit tree. Now I'm not gonna show how the exit tree works because we need to trigger a node to get out of the scene. It's gonna happen later, but every time you delete a node, you push a node out of the scene, you're moving it, this function is gonna trigger. Maybe you want to print like the player, the enemy left the main scene or the tree, or you can trigger like something that take out health or whatever you need for your games. It works as the enter tree. It works in the same exactly way. Instead of entering, it go out. Right now we can delete it. We're not gonna use it. We're gonna use process, physics process, and ready. So actually no, let's delete this one. We're gonna see. Let's keep it simple. I wanted to show you the function first. Usually every tutorial starts with the variables. I wanted to show you the function because when you create a script, it's the first thing that you see. If I create a script, let's create a node, I create a scene, a built-in script, no. Create a script, template, maybe you have a node default, you have these things with the comment. And so now you know what is going to happen with this one. Now we can proceed with our variables. So let's close everything and we open again our main node. with our ready scene. Now I wanted to show you the variable. The variable declaration is very simple. A variable is a container. It's something that stores a value and go in memory. So it goes straight, for example, into your RAM. Without going deep into how the memory management works, just note that like an integer, a string, a float, all these things have a space in memory. If I declare a variable, I just need to write var for variable. This is the key. Then you write your the name of the variable, so my variable, and this is already declared. It's gonna work. We can use it later, but I wanted to show you that you can specify, because right now this container can have any kind of value inside. It can have a string, it can have an integer. If you write like that and you declare which kind of variable is that, for example it's a string, it's gonna tell you to the compiler like, listen, this variable can accept only string value or int value, float value. So the difference between float and int is that the float can have, so right here, float can handle number with a variable with a point integer. It's like 6.4, 9.2224, like our delta, for example. When we wrote down, we saw it already, physics process delta float, we had that 0.0166666667. Meanwhile, an integer can handle integer numbers. So 5 to 100, 1999. If we write down, we write 4.2, it will take the first integer 4. Knowing this one, now we know that we can assign a value to our variable. We can tell also, okay, this variable, it starts to be a 3.2. So this is telling this variable contain this number over here. Now my string variable, I declare string, I write down hello world, is having a string. Var my mistake variable, and I declare int and I try to assign a string. It tells you that something is happening. You cannot assign a value of string as an int, because these things can only handle int. You can try to add a float, it's gonna work because it tells you that it's gonna do a round number. It's gonna take the 2, the first integer number that it finds. If I do it that way, this is a string because this is how you declare string. If I delete the type, it's gonna work. Everything's gonna put over here, it's gonna tell you that it's fine because it's a generic container. So my generic variable, even the color slightly change. Now, how can we use this variable? We can use the variable. There is a scope of variable. I can declare, let's create the function, if I write down enter tree, specify function, enter tree, print. I want to print our hello world. I just need to write down the name of the variable. So I'm having my string variable, let's disable this one. No. If I run, here we are, our hello world. This variable can be used multiple times, so I can do my string variable, and I can add a plus, and I can add another string. So I make space from ready. Now if I run, I have my combined string over here. The scope of a variable is where the variables live. If I declare it up here, the variable lives across the whole script. If I declare a variable inside this enter tree, variable inside enter equal local variable, and I try to print it here, it's gonna work. It's gonna tell you I'm a local variable. But if I want to use this variable inside here, so gonna do inside tree. There is a function called isInsideTree. IsInsideTree. This is a function already built in, so there was a mistake. Don't follow this one. So it's tell you that the inside tree is not declaring the current scope. So it's not here, and it's not inside the ready. He can't have access to this one. And this is the error that you're gonna have. It's gonna happen quite often when you're new into coding. Now let's move on with the next step. Once I have the variable and I know what is a string, I want to show you how to create your custom function. So the custom function follow the same rule as a normal function. You write function and you write my function, the name of the function. This one to specify if you want any argument. You can return void, or you can even don't write anything, it's gonna work. And then print this is a custom function. So now I have my custom function, and how do I call this custom function? Is if I click over here, nothing is gonna happen. So to call a custom function, you have these 4 nodes that I show you, or you can call this function from other scripts, but this is a little bit more advanced. Right now, let's live inside the same script. If I enter the tree and I call my function, and I click over here, we're gonna have, this is a custom function. Nothing is happening because there is a variable, but this variable is not called by anything, so it cannot print this variable. As I saw before, we can pass arguments inside the function, and we saw already as well still in our process of physics process where we pass our argument delta. So when we want to pass an argument, we just need to write my argument, and it's gonna be that I know there is a trigger because I'm gonna show you. It's gonna ask you the name, and this is a generic argument as we saw in our generic variable. You can force to be this argument a type, exactly like when you declare a variable. So I want this a type string. Yes, so it's asking for an argument. We can pass, now this is expect at least one. At least one because you can add more argument. My second argument. you can write as much as you want. Now it's expecting 2, but there is 0 passing through. So right now let's put only 1. And it's asking this one, what do we pass inside? I want to pass the local scope variable. So if I pass inside, I can write down inside enter the name of our variable that is a kind of string. If I add my variable that is kind of float, it's not gonna accept it, only a string. So let's revert it back inside enter. When I pass it through, this variable has been added to this function. The function is called, the variable lives over here in my argument. If I call it, nothing is still happening because we're not calling anywhere this variable. We're just passing it, but nothing is happening. So we can just replace this one with my argument, and here we are. I'm a local variable. You're calling your local variable from another function. So this variable now is living here, but it's not living as an inside enter. It's living as a my argument. So you can modify. If I try to write inside enter, it still doesn't work because it doesn't live over here. But if I add my argument, it exists. So this is like to don't make confusion. Another thing that you can do is my function passing an argument. You can pass a default value, like default value for my function. So if I delete this one, it's not gonna give me any error because I have a value for my argument. Now it's up to you if you want to pass it or no, if you want to override this value. If I execute again, I have my default value for my function. So I hope it's not gonna make any mistake or confusion. Just leave me a comment if you want. I can try to explain better by writing. Let's move on. Let's talk about the return value. Now let's create a function, and you can try it by yourself, and then we go over together if you want. Just pause the video and try to make it by yourself. We want to create an add function. We want to sum 2 values together. So let's call it sum, and this sum take the first integer of type int, second integer of type int. What is gonna return? It's another integer. We want that the value is an integer. So now let's create a global. We don't really care at the moment. Var first int, var second int, and let's assign some value. So 4 and 7. Let's move this one out. We can delete this one. We can delete this one. Pass. So we're passing 2 arguments and we're returning a value of type int. If we want to sum this number, we need a container that holds this value. I can write down var sum is equal to first integer plus second integer, and it's keep giving me an error. The error is not all the code path are returning a value. When you write this one that is not a void, it's expecting something to get out of this function to give back to who is calling it. So the keyword is return. You want to return something, and in this case we're gonna return the sum. So returning another integer over here. Now if my enter tree, actually let's move this one inside the enter tree maybe, because the error is because you need this one, because I saw that when I was typing over here there was the second int, so you could create some confusion. In this case you're forced to use your argument instead of the global value. So if I return a sum, if I click over here, nothing is gonna happen because we're returning something, but we're not using it at all. In order to use this sum, we can create another variable, or we can call our function and say first int, second int. So we're calling our sum. We're gonna see again what happened, and nothing is happening again because, as I say, we're returning something, but no one is telling how to look or what to do with this value. So if I need a new container, and I can do variable my sum is equal to the return value of this function. So how it works is I create a container called my sum, and I call the function passing the first integer and the second integer, and I'm expecting that this container is gonna fill up with something coming out from this function. And if I run again, nothing is gonna happen because we need to write a print, and we can print my sum. Now if I click, 7 plus 4 is equal to 11. As we saw, we got a value in return from this one. Now why it's important? Because I can call this sum from a lot of places. I can print, and I can take now my second int and put it as 2 and call it again. Let's do it in another way. We can call straight out print and the function of the first integer plus the second integer. That should work. Let's see. I can cast. This is a casting right now. I'm gonna see it later. No, actually it's not gonna work. I was expecting 2 after. That's very weird. Too few arguments for some. Oh, sorry, I forgot this one. I can delete this one now. So I can print straight out the value coming out from these things without needing of a container. This is another way how you can use it. So you want to check a value, you can just print it without creating something in memory. So if I click now, I'm gonna have to result 11 because the 4 plus 7 is 11. Then I change my integer to 2. 4 plus 2 is 6. And I'm printing out this. You can even write void here and print automatically here, but maybe you want this number to do something in another place. Now let's modify. Let's see. We have the sum. We have integer. We assign the sum. We can return a string, or we can actually sum. Okay, the sum is plus, you combine my sum. Let's see if it works. Yeah, we got an error because we're trying to combine a string plus my sum. Before you saw me write here string parenthesis. That's what I wanted to arrive. There is a thing called casting. Casting in coding is when you take a variable, something of a type, and you want to transform it to another type. In this case, we can transform my sum, that is an integer, into a string. To do this one, you just need to add string and a parenthesis and telling, okay, this is an integer, but treat this as a string. So now if I run my sim, the sum is 11. It's pretty straightforward. Maybe for a beginners can be a little more complicated, this kind of things, but with time you're gonna learn if you keep practicing of how to do. Another way to casting is, let's writing in a new thing. So I want a variable my sum as a string, and I want my sum as a string. So there is this keyword as. We want the sum to be treated as a string. This is called direct and indirect casting. Sometimes it's just like trying to say, okay, try to be a string, or sometimes it's like, now you are a string. So you're gonna have sometimes problem to try to cast. If I yeah, this case is telling you like I cannot convert the value to a string. If you see this one is telling you what the error is. It's telling you like I can't convert, this is an integer, I can treat it as a string because it's an integer. This kind of indirect casting, we're gonna see it later when we treat nodes. Right now, just like know that like in this case you're not telling this is an integer, this is a string. You're telling to the compiler, this is a string, but I wanted to try to treat it as a, this is an integer, I wanted to try to treat as a string. That's why it's not gonna work. So let's delete this one, and I want to show you the last thing before we move on. I want to return a string now, and I want to check if the sum is a odd or even number. In order to do this one, we need to have we have our sum. We create a variable odd or even. For example, there are shorter way to do it, going very long in order to understand what is going on. Odd or even. In order to check odd or even, we need to divide a number by 2, because as you see, if you divide by 2, you can have a division, and you can have as a rest 0 or 1. If it's 0, you're gonna have an even number. If you're gonna have a 1 difference, you're gonna have a odd number. In order to check this one, if I do a normal division, either sum divided by 2, I'm gonna have a number that is odd or even. Right now, even if we return, we don't really care. We do a sum of first integer plus second integer. Again, sorry, you want to pass the argument with a comma. Second integer. So oh yeah, I can't return a string right now. We don't want to return. We return this is a way to return empty string, not returning anything. So let's try again. If I do my sum, that is 11 divided by 2, we're gonna have 5, because 11 by 2 is 5 with a difference of 1. If to check instead of 5 the difference, we need to use another sign, that is the modulus sign. this one is the same as a percentage, it's gonna give you 0 or 1 or 2, 3, depends on how much you're dividing this number. So if I now run it, 11 is a odd number, I have 1. If it was if it was a even number, it was going to be 0. So how to check now? How do I tell to the compiler this is print odd or print even? Let's not doing like this way. We don't want any return. We do everything inside the function. If you want a challenge, try to return the string and print it outside inside the enter tree. So how we check if the result here is 0 or 1? There is one thing called if. It's a condition statement. So you can specify, is my odd or even is equal to 0. If you click enter, you have already the indentation. You can print the sum is even. So now let's work. As we see, the sum is even. If you want to check if the number is 1, so right now we have a condition 0 or 1, you can write else. You don't need to do any checkings because the other condition should be 1. It can be anything else. So you print the sum is odd. And if I run now, I have, this is even. Let's write with 3. This is odd. If you have more condition, you can try to do another statement. So if this one, elif, it means else if odd or even is equal to 1, you print the sum is odd. And if you want, you can still concatenate more, elif something, or you can end up with the else, print there was an error. Now nothing is gonna happen because it's 0 or 1, but for the sake of testing, we can divide by 2, and we know that 7 divided by 2 is gonna be 3. So this else statement is gonna trigger whatever any other number beside 0, 1 is gonna be. So there was an error, and everything seems to work. Now, as I said before, if I want a challenge, if you want to return a value and you try to do it, or you want to do it now, stop the video, try it, and then come back and we're gonna see it together now. So as I say, we want to return a string, and now it's gonna ask you to return path for every a value for every path. So inside the if statement, this is a path, this is a path, this is a path. So you can return the sum is even, or you can return the sum is odd. You can write without parentheses, it's gonna work as well. And then there is return, there was an error. As you saw, now everything works. And if I run, nothing is happening because I'm returning a value, but I'm calling my function without anything. If I now print my statement and these things happen, I have there was an error. If now I delete my else, I'm gonna have an error. If you're wondering why we're getting an error, it's because now we don't have as certain path, a secure path to have without the else, because it's gonna be if 0 or if 1, we can write it like that, if 1, but if it's not 0 or it's not 1, the function will continue over. And it say like, I don't have any return value. If it's gonna be 2, I don't know what to do with this number. So you need to return there was an error. So now again, if I run my function, everything works perfectly. I hope it's very clear for you, because it's very confusing at the very first beginning, especially if you're not coming from a coding background. I didn't have any coding background. I'm just like, I learned with time. It took me years before understand what I had to do. But if you manage to do with the variables and with the function and with the statement, we're gonna move on with the more in-depth coding on how to make our code to work with our node, how we can manipulate parameters inside our node, because at some point we have maybe a node 2D and we want to move our node, and why we need to create something from scratch when we can trick this parameter with the code. So let's close here this lesson and let's clear your mind, go over it, try and fail and try. My advice to learn is to stop the video, delete your code and try to create it again, and let's see if you can handle this process. In the next lesson we're gonna move on nodes and script working together, so we can start to move finally something on our 2D viewport. Thank you for watching, and if you like it, you can like my video or subscribe. I don't know how everything works on YouTube. I don't really mind. I'm doing this one for fun.